All right, let's do one more examples of transformations to make sure we understand all the concepts. So let's say, for example, I have some random function, let's call y is equal to f of x, and I transform it to y equals negative f of 2 minus half of x minus 2. All right, so remember, step number 1 is to factor. Factor all the things that are inside of the f. So it's negative f, and it's going to be negative half, and it's going to be x minus 4 minus 2. Why is it minus 4? Well, negative half times x is negative half x, and negative half times negative 4 is positive 2. So now that we've done this, let's list the transformations. So clearly we can see a negative on the outside of the f and inside of the f. So that's a reflection on both the x and y axes. So I'm just going to write them in one sentence. So reflection over the x and y axes. I wrote over, but you could write across. It really doesn't make a difference. Next is the stretch. Well, I don't see a vertical stretch because there's no number outside of the f, but there's definitely a horizontal stretch. So I'm just going to write stretch in the x direction. And remember, it's by the reciprocal. So it's in the x direction by, I should really write it by a factor of, but it's by a factor of 2. The reciprocal of half is 2. So by 2. And finally, let's do the translations. So translate, and if you observe, this is 4, so this is 4 right, so 4 units right, and it's negative 2, so it's down 2 units. All right, so we're done with we're at least writing down the reflection stretches and translations. So now let's basically use this example, our classic f of x, and we're going to transform this function using, we're going to transform that function to this. So the edge points for this classic one that we've been using throughout is 1, 2, 2, 4, and 4, 1 once again. So what we're going to do this time is go from y equals f of x to, and I'm going to write just the factored form because I don't want to confuse you. So the factored form is negative f of negative half of x minus 4, and then it's minus 2. All right. So what will this new transform function look like? So let's basically, this is our original xy. Let's see what the new xy looks like. So first, we have a reflection over the x and y axes, which means both the x, so for the y-axis, it means it affects the x's, and for the x-axis, it affects the y. So both of them are being affected. So let's check this off and say that we know there's going to be a negative here, and we know that there's going to be a negative there. Then, it says a stretch in the x direction by 2, by a factor of 2. So it's only the x. So this is going to be negative 2x. And since there's no stretch of the y's, it's simply negative y. And then finally, it's translate 4 units right and down 2 units. So 4 units right would mean plus 4 over here. And then down 2 units would be minus 2 over here. All right? And basically, if you do these calculations, 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. So if you write these, I've done these before, so but you can just basically calculate them by yourselves if you wish. It's 2, 0, negative 4, and then the last one is negative 4, negative 6, and negative 3. Now let's plot these points. So 2, negative 4, 2, negative 4 would be right about here. So 2, negative 4 would be right about here. 0, negative 6 would be right about here. And negative 4, negative 3, negative 4, and negative 3 would be right about here. All right, and now let's just connect the dots. So let's just connect the dots. So this point is connected to there. That point is connected to there. I'm just going to label it, and I'm simply going to label it as negative f of negative half of x minus 4 minus 2. So let's see if this sort of makes sense. There's a reflection across the x and y. So if I reflected this across that way, that would look something like this. And then if I reflected that way, it would look something like that. And so clearly this final transformation kind of looks like that. So I'm just going to erase those two. I just wanted to just show you if we were in the right path. So yeah, we're good with the reflections. Then we see a stretch in the x direction by 2. So this function looks smaller and this function looks wider. So yes, we've stretched in the x direction by 2. So that makes sense. And once again, the translation 4 units right and down 2 units. Like I said before, it's really a little bit hard to see the translations because it's overshadowed by the reflections and the stretches. So if you've done your calculations right, this should be good. But it's always a good idea to double check your calculations. I made sure these were correct, and you can double check them if you wish. But these are correct. All right, so that's it for all these examples for transformations, and I'll see you in the next set of videos.